As a teacher, looking for ways to excite students about science, a trip to one of the country's free, hands-on science centres is a great way to realise your goal. In London, Launchpad is the Science Museum's biggest and most popular interactive gallery.
Physics particularly has an image problem at the moment, and we've done a lot to try and change that image here by making the exhibits interesting, relevant and fun, really. Our main aim is to motivate and inspire children to come and to think more about the world around them and the physics around them. With over 50 exhibits and a variety of shows targeted at Key Stage 2 and 3, the museum actively encourages visits from schools. Schools like Hillbrook Primary.
We've visited the Science Museum today to investigate our friction topic and to look at other things that we'll be looking at throughout the year.
We'll be following Katie's Year 4s and investigating how schools can make the most of such an experience.
The new Launchpad is all about trying out lots of stuff.
We consulted teachers an awful lot on this gallery. We consulted primary school teachers, secondary school teachers and SEN teachers as well. We've put together, from their advice, what we think is a good structured visit.
Each school gets a 5-minute briefing on arrival, introducing them to the gallery's ethos and encouraging students to discuss what they find.
What could you do if you come up to something and you don't know how it works? Yeah?
I'll go and ask an explainer.
You could ask me or one of the other explainers. Who else could you ask?
Other people, your friends.
Your friends, absolutely perfect.
Then it's time for the students to get hands-on. Keeping the visit focused on topics they will be covering in the classroom, Katie heads for those exhibits that allow an investigation of forces and motion.
See if you can pull yourself closer to the yellow and see what happens. Do you slow down? Do you get faster? And why do you think that's happening? Okay? Think you can do that? Yeah. Good. When the children come and they can play with the different things hands-on, it allows them to put their knowledge into a context so that the children have something to build upon.
It's when you bring your weight in that you'll speed up. Now lean back as far as you can, keep your legs nice and straight. Now keep your legs straight, but with your arms, pull yourself to the middle. If you bend your legs, you tend to go round the side a bit. Now how dizzy are you? You all right?
Who's going to give me a push? Samira. Right, I'm going to lean back.
The best visits that I've seen here in all the years I've worked here are when teachers get absolutely involved with their children and they're leading, they're motivating, they're getting the children questioning in that frame of mind. All these tools are here for them to get the most out of, and to maximise that impact, it would be really helpful if teachers get stuck in with the kids as well.
The exhibits are grouped into 6 key curriculum areas.
We looked at what children are being taught at schools at Key Stage 2 and 3, and we designed exhibits around that. Each of the exhibits in here has gone through 3, 4, sometimes 5 prototypes until we get it right. And when I say get it right, it means that we've questioned and talked to teachers and students about what they thought the exhibit was about, what it's taught them, and the ones that you see around you are the ones that have fulfilled that test.
Each group gets an hour in the gallery. So with over 50 exhibits available, it helps if teachers think carefully about what they want out of the visit before they arrive.
The whole ethos of it really is that you choose which exhibits you want to go to, particularly highlight exhibits and areas that you're studying at the moment or about to study. So if you look at your curriculum and look at what you're doing term by term, perhaps the best thing to do is to highlight that with themes and particular exhibits in here.
This is an exhibit called the air cannon. Now it involves pulling this rope. You can lift up this really heavy bowling ball. When you release it, it builds up the pressure. Now this tube here is connected underneath via a tube to this smaller tube here. And if we can get it, if I can show it to you, there you go, we've got a nice smaller ball inside. So by building up the pressure, it acts as a force on the smaller ball and sends it flying up into the air. Some quite nice things with this is you can maybe try and get your pupils thinking about what's going on inside, about how you squash down the air and how that might build up the pressure. Also, connected with this, there's quite a lot about conservation of momentum. The bigger ball falls at a slower speed, a shorter distance, but that momentum, because it's always conserved, is transferred through the air to the smaller ball, which is a much smaller mass and takes off with a much higher velocity. So you could also try and maybe get your kids thinking about what would happen if you dropped the smaller ball. Would it have the same effect on the big ball?
Saphira's putting a push on that boat now with her hand. How is this boat going to push the boat?
Because of the fans.
But what are the fans doing? So the fans aren't touching the boat. What is it that's pushing the sail? Air. Let's see what our explainer has to say about our idea.
Let's see if we put it like that. Let's see what happens. Oh no! Which way is it going? Oopsie!
We train explainers to facilitate. We don't train them to explain, actually, even though that's the word we use. We train them to ask questions, to find out where your kids are, what kind of thoughts they have about the exhibits in here, and to push them towards the next level.
Where do you think we should put the sail?
Why have you put it there, Renee? Why will it move that way?
Because the wind is going in here and going out there. So if the wind is going in that direction, that makes the boat go in the opposite direction. So let's try and put it here.
There we go, look at that. Wow, all the way to London town.
Yay!
If you think about Launchpad being your laboratory and the explainers here to help your students get the best of it, that's the approach that we would have.
The wind needs to go that way, so the boat goes that way, doesn't it?
It's very difficult for the children to imagine what we're trying to get across to them when they have nothing to compare it to. And the visit to the Science Museum allows them that flexibility to investigate in their own capacities and be able to understand better.
We have a lot of different varieties of exhibits around, some which are cooperative, some which are contemplative. Very often they present a natural phenomena in front of you and something unusual happens, something odd, which will question what you think of the world. And that's really what we're after. We're getting students, adults, teachers to really think about the world around them and build on their knowledge of physics and chemistry.
This exhibit is called Watching Water Freeze. It's got a really cold surface. So obviously, as soon as the water hits it, it starts to turn into ice crystals. By looking through these Polaroid lenses that we've got up here, you can start to see them really, really well. And each time this forms, it forms a unique pattern. So you get some really beautiful patterns forming on here. You might want to ask your pupils the difference in the molecular makeup between a liquid and a solid. It's an everyday phenomenon. Something that you see every day is water freezing with your ice cubes and that sort of thing. But this really brings it into life. You don't often see the crystals actually form in front of you. This is an exhibit called Icy Bodies. It's one of the few exhibits that we have in the Launchpad which isn't actually hands-on. We're getting dry ice, which is frozen carbon dioxide at minus 78 degrees. It's coming out through this conveyor belt down here. As soon as it hits the water, which is at 25 degrees centigrade, roughly, room temperature, it immediately boils, so it turns straight from a solid to a gas. Now, as it boils off, it forms some of these beautiful patterns. They're really nice to look at. It's quite unusual with boiling at such a low temperature. A lot of students might only be used to water, which will boil at 100 degrees, freeze at 0. So this might bring into sort of the mind of the pupils that perhaps not everything boils and melts at those temperatures. And perhaps why is that?
Right, good afternoon, welcome to the Science Museum, welcome to the Launchpad here at the Science Museum, and welcome to the Rocket Show. Now,
Each visit also includes the opportunity to see a 20-minute show.
Newton's third law basically says, if you push something in one direction, you push yourself in the opposite direction with just as much force. Primarily it's about rockets, but it's also an introduction into Newton's laws of motion. So there is lots of science about the rocket as well, but also how things move. Right, now what comes out the back of a rocket?
Fire.
Fire, yeah. I have got the helmet of fire. We're going to pop this on. You're quite excited. How many people are usually excited when I put on this? Right. So after 3, I just want to push. I'm going to see what happens to the back of our rocket. So after 3, you ready? 3, 2, 1. Right, take one finger. Which way did the front of our rocket go? Forwards. Which way did the fire go? Backwards, in the opposite direction. Round of applause for my 2 volunteers. Cheers, guys. Let's undo this. Would you like to see a real rocket that we are going to launch here today? Yeah? Right. Drum roll on the floor. Drum roll on the floor. Ladies and gentlemen, boys and girls, I present to you our very own Launchable Science Museum rockets. Now, I know it doesn't look like a rocket, all right, it doesn't look like a rocket, but we will get it to go up. And one of the things we need to get it to go up is rocket fuel. Pop your hands over your ears, and I'll show you how flammable our hydrogen is and why we use it in rocket fuel. You ready? After 3. 3, 2, 1. Hands over ears. Hands over ears.
It was a fantastic opportunity for them to learn about the topic that we're about to do. They saw how forces are actually working in the environment and how that knowledge is applied to very exciting principles like space travel. A lot of the experiments and the learning that I will be teaching them throughout the next couple of weeks will link very nicely to this.
You ready? 3.
Classroom resources available online can help with any follow-up work.
There's very simple ideas for rockets as well, little Alka-Seltzer rockets. Or water rockets you can make at school. So there might be some experiments that they can do in their own classroom on the playground that might be able to help what they've learned here today.
There are many science centres across the country that encourage visits from schools. But for those who can't make it, many also have websites featuring other resources, including ideas for classroom experiments and games.
Well, it starts out very simple. You've got a ball and you've got a goal, and you've got to get one to the other. What we're hoping children take away from this and will learn is the idea of test and observe. So things like you've got a problem in front of you and you've got some things that you can use to solve it, and you don't know the answer right away, and you maybe move things around and hit test and it doesn't work, and you keep playing with it. So it's about the process of science and how even if you don't get the answer straight away, you keep testing and you will get there eventually.
Resources like this can work on the interactive whiteboard or be used as a homework activity.
Have them go home, try it out on their computers, complete the level, and then draw the path that the ball took and explain why the ball went that way. You get an understanding if they know the concepts involved and how the ball interacted with what they've done to it. And then you can discuss that back in the classroom and who chose what options. A lot of the games, a lot of the levels have different solutions, and it's really great to see who came up with what.
It's gone off track! It's gone off course, but we made it to London, yay!
The trip to the Science Museum is a fantastic opportunity for the children to develop their own understanding and also take on board new knowledge which they can then apply in the classroom further.